You are on to Dr. OJ tutorial. In this video, we want to look at another example on how to integrate from the first principle. Stay blessed. Now, we want to integrate from the first principle. Now, the interval of our integration is 0 to 1. So we have 0, 1 as the boundary points. That is, we have the end points are 0 and 1. So in this case now, without wasting our time, the change in the end point is going to what? 1 minus 0 all over n, because we are partitioning it into n's equal parts. And so you can equally have from the left end points, our xi will be equals to I all over n. Okay, whereas our f of x now, that is f of xi will be equal to what? I all over n squared. Beautiful, because our f of x is given to the x squared. Now, by bringing them together using the concept of Riemann integration, we're going to have what? Summation, summation f of xi multiplied by the change in the x as I moving from 0 to n minus 1 will now be equal to I all over n squared multiplied by changing x here is 1 over n, 1 minus 0. So 1 all over n. So this will be what? This will be what? I squared all over n cubed. So I squared all over n cubed. That is multiplying this by this, you have that. Okay? So that means we are having what? Summation I moving from 0 to n minus 1 multiplying this. That is when you, okay, if there's an omission here, there's an omission of summation here. Okay, I moving from 0 to n minus 1. Now, so we can factor out our n over 3, n raised to power 3 as what? 1 all over n cubed. We let what? Sigma summation I move from 0 to n minus 1 I squared. Beautiful. And note, the summation I squared, is from what? Is from the summation of this first n squared of natural numbers, which we are going to get by using your mathematical induction. That will give you what? That will give us n into n minus 1 bracket 2n minus 1 all over 6. You can check that through your mathematical induction. That is, find the sum of all squares, the first n natural numbers, the square of all the first n natural numbers. It will give you this. So don't forget why your I is taken from 0 to n minus 1. So that now implies that we could have what? So we now have from here this implies that 1 all over n cubed, the whole of this now is this. Okay? So we can have what? Dot n into n minus 1, 2n minus 1 all over 6. So n will cancel 1 n here. So you'll be left what? N squared. So we can continue with that and have it this way. So now have, so what we are trying to do now is what? Summation of all this. So we have what? We have n in n minus 1 into 2n minus 1 all over 6n squared. That's what we are going to get. All right, that is summation of multiplying this by that. So which implies that now take the limits as n tends to infinity of n minus 1, 2n minus 1 all over 6n squared. So by the time we expand this, we have 2n squared minus n minus 2n plus 1 all over 6n squared. So that will give us what? 2n squared minus 3n plus 1 all over 6n squared. Now divide both numerator and denominator by n squared, which is the higher degree of n. So you have what? 2n squared all over n squared minus 3n all over n squared plus 1 all over n squared all over 6n squared all over n squared. So this will cancel this out. So you have what left? This we cancel this out. You have what? 2 minus 1n, we cancel 1 here. 3 all over n plus 1 all over n squared all over 6. Yes? So, with that, we now take our limits. We take our limits as n tends to infinity. We take our limit as n tends to what? Infinity. So, now, limits as n tends to infinity of 2 minus 3 all over n plus 1 all over n squared all over 6. So that will be what? 2 minus 0 plus 0 all over 6. That will be 2 all over 6, which is equal to what? 1 all over 3. So the answer is 1 all over 3. So you can check. The integral of x squared moving from 0 to 1 dx. So if you integrate x squared, you have x cubed all over 3 with the limits 1 and 0. So using 1, you have 1 raised to power 3 is 1 over 3 minus using 0 as x 0 over 3. So that's 1 all over 3. So we are correct. So that is the answer. So with this, we have come to the end of another example to illustrate the integration of functions from the first principle. Don't forget to click on the notification bell so that each time I upload a video, you'll be duly notified. God bless you.